questions about anything. Okay, so I'm going to talk about what we need to do for this example here. So what we're going to do, ignore for a second that we're going to create a script that does this. What we're going to do is calculate how many people live in each watershed. Okay? So this is a very common exercise that's done in GIS. It's sometimes called, first thing I'm going to do is close all this and open the lab data, because we're going to be dealing with the lab data now. So now I go to CTEMP, lab data. Where I put it? There it is. I'm just going to add both of these. So yeah, this is what I was saying is this is a very common task in ArcGIS, particularly when we have a data set like watersheds. See the watersheds data set that's coarser than the underlying population data. Here's the population data. We want to find out how many people, how many South Mississippians live in each of these watersheds. Okay. All right. Now look at this, though. Okay, I'm going to make the watersheds hollow, and I'm going to make the outline color like red. That's so big. There we go. I'll actually make the outline width a little bit bigger. All right, look at this, for example. Do the watersheds follow the census tracts at all anywhere? It doesn't look like it. They don't. Okay. Maybe it was meant to follow it, like right through here. See how this census tract kind of, but it doesn't exactly follow it. So we have a bunch of watersheds, and we have a bunch of census tracts. We want to find out how many people live in each watershed. That's the ideal. But there are census tracts like this one that we're going to have to divide in half. We're going to have to say, okay, some of the people live here, and some of the people live here. And some of the people live here, and some of the people live here. In the absence of any ancillary information, what we're going to do is we're going to assign people in each watershed based on the percentage of area of a particular tract has in each watershed. So in other words, if 50% of one tract lies in this watershed, 50% of its people are going to be assigned into that one. And if 50% is in this one, then there'll be 50% of the people assigned into that one. Or if it's 10% in this one and 20% in that one, and maybe 70% in the third one. We need to divvy up those people that way. Okay? So it's kind of a complex problem. It's not that complex. So for example, if 100 people live in a tract, 80% of that tract area falls in a watershed, then 80% of the people would be counted for that watershed. Okay? So what we want to know is the total percentage of people in each watershed. So the way that this process usually goes with vector data like we have here is that we first do an intersect. Like we first intersect the watershed boundaries and the census tract boundaries. What that does is it will give us it'll break apart all of the boundaries that are not common. So this watershed, there'll be a new line right down through there. We could intersect or we could do union, it doesn't matter. What's the difference between union and intersect, real quick? Back from ArcGIS world. Yeah, in this overlay. Which one's what? I can't hear really well. Okay, so an intersect, like let's say that these are the census tract in blue, and this circle is a watershed. The intersect, the output is only going to be the result of where those two features touch. That's what you were trying to describe? Well, okay, good. All right, the union is like this. So either one will actually work because we're interested in just finding out the total population of the watershed in Mississippi. So we're not interested in finding out who lives over here and who lives over here and who lives over here. Okay. So in either case it'll work. What we're going to get is an intersection. And once the intersection's done, we're going to get all the attributes of both the layers, of both the census tracts and the watersheds. Okay. All right, now look what we have here. We have already a shape area. Okay, what does this represent with a shape area? What is that number? It's the area of the census tract in this case. If we open up the watersheds layer, it's the area of the watershed, right? We're not as concerned about the area of the watershed. So we've got this area of the shape area, right? So we're interested in finding out the proportion of an area that's in a particular watershed. So one way we could do that is to find out what the area is before we did the overlay, and then find out what the area is after we do the overlay. Okay. So the first step that we need to do is what's going to happen after we do an intersect? How many shape area fields are we going to have? I could test it real quick. What did you say? Something in the code said something?
5.
That would be nice. But I'm going to intersect watersheds and census tracts, and I'm not going to care where it saves it. Oh, it is a different thing. Thank you. Intersect. Watersheds, census tracts. I'm going to run it. I don't care where it's going to save it because I'm just going to delete it in a second. So here's the intersect. I'm going to open it up. And I do have the watershed that it was in, which is important. But look, I only have one shape area. Okay. So now, if I zoom in here, let's say, where I used to have just one census tract right here, if I turn this off, see, I used to have one census tract. I now have 1, 2, 3, 4, 5 census tracts. Because these are watershed boundaries that got superimposed onto my census tract boundaries. So I used to have a population there. What was the population of this census tract? It was 6,370. So what I want to do is take those 6,370 people and spread them out into these other polygons, but by percentage of population. Okay? So once we start actually doing these, you should be taking notes as to how it's done. Because you're going to have to implement it in Python. All right? So I want to spread those out, so that each of these will have that. Let's see what they have right now. Let's go ahead and select each of those values. I'll turn this off. Oops. Okay, so let's look and see what the population in each of those is. The population in all of those polygons is 6,370. That's not right, but that's what we expected to happen when we did the overlay. We expected all of the attributes to go in all of the new polygons that were created. So we need to find a way to take that 6,370, multiply it by a percentage, and then we'll get our new value. Okay? All right. So the step, the percentage of the, so right now, this is the new area, right? This is that area right here, 171568426. That's the area of this largest polygon. If we knew the area of the entire census tract, we could take that area and, well, we could take that value and divide it by the area of the total census tract. So in other words, if the total census tract was 1,000, and this area now, let's just say it's 10, 10 divided by 1,000 would give us 1/10. Then we can multiply 6,370 by 1/10, and we'd get the amount of people that were assigned to that little portion of the polygon. Okay. All right. So, how do we do that? Well, yeah.
Now, I guess for this, are we assuming that the population is evenly distributed across the entire
Yes.
tract?
Yes. That's what I meant at the beginning when I said, since we don't have any other information, we're going to do that. And it does say that in the labs. We're distributing it. We're distributing that based on the percentage of area a particular has in each watershed. Well, I didn't explicitly say it. That's what I meant. Is that we're just distributing it based on area. But if we had, like, let's say we had city limits, or we had land cover data, then we could distribute people based on land cover data and area, or something like that. But that'd get a little bit more complicated. So I meant to make the example fairly uncomplicated. All right. So if these were like census blocks, it would be even better. Then the smaller the census data that you're trying to disaggregate is, the better, because you could assume things would be more evenly distributed inside of those areas. Okay, so we don't have the previous area in there, so this doesn't even really work for us. But that's really easy to calculate. How could we preserve this? So let's open this back up. See this shape area field? How could we preserve that? We want to hold on to that value, that shape area value. Field, we want to keep that, and we want to carry that over and have that be in there once we do the intersect. But ArcGIS overwrites it with the new shape areas. But we want to keep that shape area. How could we do that?
We could create a new field and just call it original shape area.
Exactly. We create a new field, and we calculate the area. We calculate this area, the shape area, into that field. And we call it original area or something. Okay? All right, so that is the first step. So once we do this in ArcGIS, when we do this in Python, we need to do this. But let's do it in ArcGIS first. And then all you'll do is call this from Python. So the first step is to add a new field. Okay, so we need to find the tool that adds a new field. Now, you probably do know you could go like this, add field. Well, that's not going to work because we can't call the GUI. But thankfully, there's an Arc toolbox called add field. So let's go to that toolbox. That's under data management and then fields, and it's called add field. in Python, we have to use the toolboxes. We can't tell it to press a button on the GUI.
Or you can't just do like add field, like a tool inside the toolbox.
No, we do, like, we do just call the tool inside the toolbox. So we run this tool right here.
But it doesn't need to know.
No, well, this is the syntax. So the name of the tool is @field_management. Okay? So you need to take this, line and put it in there. Okay? Now, let's look at the input parameters here. So the table is going to be what? The input table. Yes, the census tracts. Now, it doesn't matter that census tract isn't just a table. So ArcGIS will run this tool on just a table, or it'll run it on a feature file. So we need to run that. And then what's the field name going to be? That's going to be the field that we want to add. I like the suggestion from down on the coast. We call it like original area or something. Okay, so that's going to be the field name. The field type, what's that going to be?
Defaults to long.
It defaults to long. Now we're dealing with such large areas, it probably doesn't matter. But let's say we were dealing with smaller areas that were like let's say our units were hectares and we're dealing with pretty small areas. We want points and decimal places. I think it's actually best to use double so we can get a decimal place. All right, and then we can leave precision and scale blank, because it'll just choose the biggest one if we leave them blank. We can leave everything else blank, actually. So let's go ahead and run it inside of our toolbox right now, and then in a second, once we get all the way through the process, which it isn't very long, we'll start writing in Python. Okay, so that needs to be C tracks. And again, you probably need to set your workspace there, or we could practice this by actually choosing. So you notice that those two are slightly different. If I leave this as C tracks, I'm saying use this version that's loaded in ArcGIS. If I pick this, it's actually picking the file on disk. All right, the field name, I like that suggestion for original area. Original. I'm just going to do orig area. Orig area and make it double. So everything else can be left blank. It's going to be the original area, it's going to be double, and it's going to be census tracts. Everything else is fine the way it is. And when I run that, it's going to add that new field to the data. Now, this is a tool that actually doesn't give you a new data set. So one thing is that when we actually go to write this, we're going to have to delete this field off. Just because I want you to actually write the whole thing. So if you skip this in your code, then you won't get full credit. So you gotta include it. You gotta actually run it. All right. Now, how do we get the shape area into the original area field? What's that tool called from people that might have done some GIS before? Calculate areas. No, just calculate. Just calculate. Now, we could, again, there's a GUI interface where we can right-click on it and say Field Calculator, but we can't use that. We need to use the tool that does the exact same thing, and it's called Calculate Field. Okay? All right, so Calculate Field, the input table is going to be the same. The field name is going to be, this is the field that will be updated. So it's the field that's going to get the value. Which field is that? Yeah, it's going to be original area or orig area if you didn't know how to spell and were like me. All right, now the expression is the way that the code gets typed. So pay attention here, because notice when you hit this little button, if we want it to equal shape area, it has to look like that. And see how it's got these little brackets around it? Bracket, shape area, bracket. Now, when we run this in Python, see, I just canceled out of that. If you go to Python and you hit this little guy, it actually has exclamation points. Exclamation point, shape area, exclamation point. Okay. So, yeah, you're going to have to make it slightly different in Python, basically. So why don't we just make sure that says Python, because we're going to be using Python later. And then this has to say exclamation point, shape area, exclamation point. It always makes me want to shout shape area. Just kidding. All right, so now we're going to run that guy. Go ahead.
But in Python, as we're putting that in as a parameter, we still use that syntax,
Yeah.
still exclamation point.
Let's look at the tool help, but you actually can tell it, I'm pretty sure, to run expression type. You actually can give it a VB expression. So like, see here, this is the parameter. You actually could still tell it that it's a VB expression.
In Python.
Yeah, but I don't like to do that. Sometimes it gets confusing. So here's the syntax here. Calculate field management. You put the exclamation point, the name of the field, exclamation point, and then quote, quote. And then I just usually use, if you use Python, the plain old Python, it's using the latest version of Python. A lot of things changed in ArcGIS at 9.3. 9.3 was the last version of 9. And so they leave that in for backwards compatibility. So I just usually write Python. Now, we'll talk about this later, this expression. I don't know if you ever dealt with this before in any of your other classes, but you can actually run a whole Python expression. It has to be Python if you use the code block. You can actually run a whole Python expression here, and it will feed that into there. So, all right. But there's not much reason to do that here, because you could just write your Python code in Python itself. Okay, so I'm going to say OK, and this is going to run. And now what it's going to do is inside of census tracts, I'm going to have the area updated. So now I've got the area updated. So far, I've run add field and calculate field. So write that down somewhere, because you're going to need to run them in ArcGIS. So add field, calculate field. So now, what's the next step? Now I can go back and do what? Yeah, the overlay. Intersect, union, it doesn't matter. Because what's going to happen is you're going to get a bunch of zeros if you do union. And zero is going to add up to 0. I think the intersect's a little cleaner. What's that? Oh. So let's do the intersect. So go back to our toolbox and run intersect, which is under overlay, intersect. And if we intersect our two layers, the watersheds and the census tracts, let's look at the Python syntax here real quick, because we're going to have to run it in Python. And it'll be a little bit different. Look at how your in features is going to be a list. It's going to ask for a list. So remember a list? I should have actually asked, what data type is this? It's a list, but it's a list of what? It's not a list of files. Yeah, it's a list of strings that represent files. If you look at the help, it'll actually say a list of the input features or layers. You don't need to worry about priority ranks. We're only going to have 2, so we're just going to going to overlay them. All right, none of these other things we really need to worry about. If we did want to get fancy, we could say that, okay, we don't actually, we want all. I was wondering if there was a list option in the join attributes, but there's not. If there was a list option, the only one we really need is that, actually there's three we need. We need to know what watershed it's in, what census tract it's in, and the original area. And then we're gonna use the new area to calculate. Okay. All right, so we can just leave this all. We hit OK. It's going to run through this time. And this is one where you need to remember where you put it. So when you run it in Python, remember the path that you put it into. So now, looking at this attribute table, I have, I'll make this a little bit bigger. I have my original area right here, and I have my shape area right here. So I have two fields, original area and shape area. So the formula is really simple. To find out the population of that polygon, I take the population, the old population, and I multiply it by the original area divided by the shape area. So this is original area, shape area divided by original area. Shape area divided by original area times the population. Because this is going to be a proportion, and this is the population. So now I'm going to, what if the shape area and the original area are the same? What's going to happen? What if the shape area and the original area are the same? What's that? The population will be the same. What does that mean spatially if the shape area and the original area are the same? It was entirely contained in one watershed. That's what he was saying, right? It's entirely contained in one watershed, and so the population should be the same. If the shape area divided by the original area was less than 1, then it's only a portion of that population is in that area. All right? So, let's create a new, so the next step after the intersect is to create a new area, a new field that's going to represent the population in that new area. So we're going to add a field. Now, somebody on the coast said before, long might be a good choice here. And it might be. You can make arguments either way. We're talking about people here. So there's only going to be one person or no person. But we could save the rounding till the very end, because we're going to do another step. Okay? So I'm going to say let's leave it at a double, so that we save the rounding to the end. Remember, that's always good practice in math. So this is going to get some half and thirds and millionths of people, but that's fine. And so we're going to call this new pop. Stands for new population. I don't know if that's the best one. Oh, I did that the wrong way, right? I just told you can't do it that way. So we're going to do it through add field again. If you did it the other way, it doesn't matter, because right now we're just trying to show the steps. So, yeah.
I want to clarify real quick. You said that math is going to be the original area divided by the shape area multiplied by the whole pop.
The shape area divided by the original area multiplied by the pop. The old population. Yep. The original area has to be the denominator, because it's always going to be the same or larger than the new area. The new area is always going to be smaller or the same size as the original. So I'm going to call this new pop, and I'm going to make this double, and then I'm going to say, okay, I don't think I have to change anything. So now it's going to add that field on. So I added that field on there, this new pop field. And the only thing left for me to do is to now go back to our toolbox and calculate the value into that field. that I need. So this one will be a little bit more complicated, but still not really complicated. So the field name that's going to get the value is what? New pop. And the expression, I'm going to go ahead and change it to Python before I even go into it. The expression is going to be pretty simple. It's going to be the area divided by the original area times the population. And if you want to put in parentheses, I always do. So it looks like this. Because this is a proportion of two areas, and this is a population. Let's see if this runs. The only thing I can think of is that some of the original areas might be zeros. If they are, then we need to do something to get rid of them. So I'm going to run it. See if I get an error. I shouldn't get any zeros because we didn't have any zero areas to begin with. Now we're going to get some zeros in population, but that's because they didn't have any population to begin with in those census tracts. See what I'm saying? Which code?
The one that you put in for the new, to get the new pop, like divided by.
Oh, yeah. Geoprocessing results. So I'm looking back at this one right here. So I just used the field calculator to do this. I actually type it in myself. It's much easier to hit this little guy right here and just type it in. And in fact, when you want to run it in Python, you could just copy and paste this. All right. So now, if we look at this attribute table, we have the population by census tracts. Processing. This is the population by census tract. Or not by census tract, by pieces of census tracts that are bisected by watersheds. Okay. So let's right click here and look at the statistics. So what's the sum? The sum is 545544. So that should be really close to the population of census tracts if we just look at this field. Oh, I know why. Why is that one so much smaller? I mean, it's around the same thing. It's pretty close. It's okay. It's expected. What's that? Yeah, exactly. So if we had done a union, which I think is what I did last time we did this, if we did a union, we would have been fine. So it chopped off all this area, and it figured out who was in there. Okay. In practice, it probably actually isn't good. This area is in the water. Nobody lives here, but we assign people out there. So, like, let's say we had a land water data set first. We could actually run that on there and just chopped out all the land, the water area to begin with. If people don't live here. Yeah, clip it, exactly, that's what I meant. Good. Okay, so that's fine. That number works. Now, what we have this number right here. What if I want to answer the question, how many people, an estimate of how many people live in each watershed? When you think of a GIS tool that I can run C-Tracks on that would let me do that? Well, spatial statistics is a whole toolbox. So there is a tool in spatial statistics that would work, I'm pretty sure. Zonal stats would be the proper tool in in raster to do it with. Okay, let's see if there is actually. I don't know if there is one in there. There's actually two that will work that I'm thinking of. It's kind of like that. So let's think about what we're trying to do. So here I've got a bunch of population numbers, and anytime the watershed value is the same, see this watershed value 1, 2, 1. Anytime it's the same, I want to take that value 352 or 20. Those are both in 1. I want to add those, and I want to add all the 2's together and all the 3's together, and so on. Okay. This is actually a tool called it's actually called Dissolve that will work. So Dissolve will remove all the boundaries. If there's a common variable, it will remove all the values, and then it will come up with a summary statistic for all the values that are common. It's oftentimes the right answer when we're dealing with vector data and we think we should do a zonal sum or a zonal mean or whatever. Who said? I think it was actually that said zonal, but it's often the vector equivalent. So we're going to do a dissolve here. We're going to dissolve the intersect data, and the dissolve field says, okay, everything that is the same what do you want to dissolve? So here we're going to check the watershed, the unique identifier from the watershed data. Everything that has the same unique identifier for the watershed is going to be pushed into the same polygon. And then we can choose what statistics we want. We want to take the new population and get the total, or the sum. So what that's doing is saying anything that was a watershed, we're going to group it together in the same polygon, and we're going to take all of the new population values for each one of those and add them together. We're going to sum them up. And that'll give us the new population for those watersheds. The total new population. If we selected mean, it would give us the average. That doesn't have any meaning for us in this scenario. Okay. Oh, so once I selected the field, then I could add the sum over to the right of it. Now this part down here, it says create multi-part features. We want to do that. If we don't do that, then in our case it doesn't matter, but let's say we don't have anything like this. I probably shouldn't draw it on the board. For some reason, and this might actually be this way, I should look at the data. Let's say we had, this is a watershed. Whoops, that's not the right thing. I just want to draw. Let's say we had a watershed that looked like this. And then we had a census tract that looked like, I'm going to use a different color. Our census tract looked like this. Okay, so this polygon right here and this polygon right here would have the exact same watershed and census tract data, right? Okay, so when we went to dissolve, if we didn't say that we wanted those to be in the same, if we didn't say create multi-part features, it would create two different polygons there. And we want that to be one polygon because we want all the information together. These would still be two different rows in our table if we didn't check multi-part features. So I'm gonna leave that checked and say okay. and I'm going to get a final output data set. So this will be your final output data set, and it looks like this. Okay, looks kind of like the watershed boundaries, but now they're clipped to the. And when I said I think our data does do that, this is exactly what happened right here. You see how this polygon right here is separated from that polygon? But if I click, they're the same polygon because I said, yeah, create multi-part features. So now when we look in the data, we have a data set that answers our question. So this is the sum of the new population field. So that's the sum of the population in each watershed. That's the sum of the population in each watershed. So we ran add field, calculate field, then we did an intersect. Hopefully somebody was taking notes and can verify this. Then we did an intersect, then we did another add field and another calculate field, then we did a dissolve. So you should have, from my calculations, 6 lines of code that do each of those. So you should be running 6 different ArcPy commands in your code, okay? In addition to setting up the workspace if you want to. That might be useful because then you won't have to put the full path each time. You might want to set override outputs equal to true so that every time your code fails, you can rerun it. And optionally, you might want to be feeding in the values as separate variables, or you could just put them all in. Okay. But this is what your output should look like, and those are the numbers that your output should have within it. Okay. All right. So before I let you go on this, let's start it up. Let's start up the process. So I'm just going to go here and create a new file. And I'm going to save this as temp SPA week 5. I'm going to call this 2018 Raber 5.1. It's the only one to turn in this time. Okay? All right. So from now on, lots of your scripts are going to start with import ArcPy. Okay? And then I'm going to go over. Whoops. I'm going to go over to this guy and paste that in there. I'm going to use the C. Where did I put it? I put it under C lab data. There we go. So that's going to be my path. So your path should be the path to your lab data. Okay? So you should start with something like this. By the way, I'm going to, at this point, before I go that far, I'm going to go back to the census tract data and delete this original area field. Because if I don't, then when I try to add the field, I forget where it was. It's 10.2 or 10.3. Prior to that, it would raise an error if you tried to add a field and the field already existed. After 10 point something, I forget what it is, if the field already existed, it would just ignore it, and it would assume that you were just trying to recreate that field. So we have different versions on the coast and here, so I don't know what it would do for sure, but I just deleted that new field so that I could do it in code. Now I'm going to shut down ArcGIS. I'm going to do it here. Okay? All right. So I've got those 6 things. Add field to hold org area.
do file locations for portable hard drive?
You should be able to. Is it not working?
I was having issues with it when we were selecting the census tract and the tools. You had mentioned to select it from the file destination. With mine on my thumb drive, so I had to just do it with the layer, but it all worked out.
Yeah, you should be able to. I'm not exactly sure why.
So are you saying that workspaces, where we're saving all of our information or wherever our default database we are now?
You can choose either one you want, but you'll only be able to use the short name of the thing that you're as your workspace. So I'm going to read and write all my data to the same location so that my workspace, so I can use the short name for anything. Your workspace is just, your workspace is anytime you have a variable that's called, my data, and you call it ctracks. Anytime you use, sorry, I need to say equals. Anytime you use my data to access it, it's going to append this onto the front of it. So if I wanted to access data anywhere else, I just have to reference it by the full path. So all it's doing is allowing you to shortcut to data. So it's a shortcut for writing the path to data, whether or not it's input or output data. It doesn't care. Does that make sense?
Yes, sir.
It doesn't. Yeah. So to answer your question, it's whatever data you want. This is just a shortcut, so you don't have to keep typing this over and over again. So if you have more input or more outputs, then you can choose whichever one you want. Go ahead. Sorry, somebody else had a question.
Yeah, when you're changing your environment settings, you have a separate line for each setting.
You have to have a separate line for each setting, yeah.
Okay.
Yeah, you can't, there is tuple assignment. I'm not sure if it would work. We learned about that earlier. It's kind of clunky though. I don't know if I would do that. Let me see if this will run. I'm not sure that that'll work with inside of the module, but theoretically it should work. Looks like it does. I don't think it looks as good as putting it on a separate line. But yeah, I guess you could say, because other programming languages have a with statement. The with ability. Let's see. I'm pretty sure that you can. It's
Well, it seems like it's more to do it on a separate line.
yeah.
When you're writing the toolbox function, can you break all of the parameters and do it on the separate line? As long as you intend correctly?
No. The toolbox parameters are part of a function, so you need to give those in. You need to put those all spaced out. So this is how it would work in some other languages. Let me just see if maybe that's all. That does look like it works. So that's another option. No, did that just fail? No, that didn't. Yeah, that did fail. Yeah, okay. So that did not work. Usually, it's not very common for you to have more than 2 or 3, for you to have more than 2 or 3 of these, things, workspace, override output. There is, I'll have to import ArcPy twice. There is a way to make it a little bit shorter. So you can actually name something, you can go like this. You can name a module that you import. So I could go import arcpy.env as E. Let's just say EE in case there's already an E. Then you could just write EE and EE. That'd make it a little bit shorter. I know that works. See, that worked without an error. So you can rename you can rename a module. I could just say import arcpy as EE and then always call it EE. Or I can import any anything that, because env is a it's basically a collection of properties, and so we've renamed that EE. Right. You just would have to remember that you did that. And then, okay, in a very special case, you would have to make sure you never wanted to use the word workspace or override outputs. It is possible to import everything. You could just say from arcpy.env import star. And what this does is it makes everything in arcpy.env, it makes those it makes those global level variables. So now workspace is a variable, but I can't ever use the word workspace now because it will be ambiguous. But
Did you do that with other variables? Just add the import star, make it global?
which other variables?
Any of you just do any programming. Is that the way to make a global variable? Import star?
Yeah, except for that didn't work. I could do. I know it'll work like this, but then I'd still have to do env dot. Well, it's not the way to make a global variable, but it's a way to make the variables inside of a module global, to not have a name. See, that did work. That ran. It didn't work to say arcpy.env import star, but it did work to just say arcpy import. So I'm just saying, from arcpy, import everything. I don't ever want to have to type arcpy to reference anything. You can do that. So now I could just type in buffer or whatever the names were. I don't no longer have to type arcpy. The only problem with that is that if arcpy imports anything that conflicts with anything else that I've imported, if it has a similar name, I'm going to get an error because I've created a global variable of everything inside of arcpy by doing this. So if I import something else from another module, like let's say arcpy has a square root function, arcpy.sqrt. I don't know if it does. But if I imported math and arcpy in this manner, then the square root's going to conflict. So I don't think it's great practice to do it that way, but it is possible. I like to just type it. I mean, arcpy is not that long. But there are people that I've seen in their code a lot that make it shorter. So import arcpy as AP or something. And then they could call it AP everywhere else in their code. I've seen people do that quite a bit. Particularly with longer modules. ArcPy is a fairly short name. We didn't get to that part. I'm going to bring it up next week. But a NumPy is something for bringing up, for using arrays, and I see this a lot. So people call NumPy as MP, but that's for a different day. Okay, so we're going to intersect C tracts and watersheds, and then add new field for pop, and then finally, oh wait, not finally, calculate new pop. It's going to be old pop times, it's just kind of like a, and then so those are your steps to get the answer that you want. So what does this say? Add field to hold origin area. Add field to store original area. I like that better. So let's do the first one, because you're going to need to do them all. Okay. So the first one, like I said, what I like to do is, I already closed down ArcGIS, but I'm going to open it again. I like to get out of the help. I like to get the proper syntax. We don't actually need ArcGIS to do that. Do it right here. So I'm just going to go ArcPy, and I'm going to say add field, and I'm sure it'll show up. Yep, it does. It's the ArcGIS Pro syntax though, and I said 99% is the same, but just in case, I'm going to say I'm going to type in ArcMap, add field. Wow, that's like a blast from the past, 9.3. Still ArcGIS Pro. Calculate, no, that's calculate field. There we go. That's 10.3. Oh, here we can go to 10.5, 10.4, 10.6. Mm-hmm. Yep. Well, we're adding. Yeah, actually, so Ella is asking programmatically, could we, and I had to think about it for a second, but could we add this new field in at the same time? So we run both add fields at the same time? Yes, there's no reason we can't. Both of them, so, but you're only going to be able to calculate this field. You have to calculate this field, sorry, before you do the intersect, and you're only going to be able to calculate this field after you do the intersect. So you can do it that way, but you're going to get you're going to have an empty field when you go to do the calculations, which is fine. Okay, so yes, you could add them both right here. So I have that code up here as an example. So I'm going to just copy this over to here, and I need to modify this so that the input features are the right input features. The field name is the right name. It's not a text anymore, it's a double. So I just need to change all those values. And I don't really need anything else. So you type in double, whoops. I think it has to be all caps. Let's look. Yep, it looks like it has to be all caps there, double. Okay, so what is the feature, any input feature is going to be? What's that? The C tracks, yes. And let's see. It's just called C tracks. So C tracks, like that. But what's wrong? I have to put quotes because I literally want to give it the name C tracks. I could put input up here, input data, and then I could actually write input data right there. All right, and then what's the, I don't need to put the file type of the in because this is a file geodatabase. So this is inside of a file geodatabase, so I don't need .shape. If I did put .shape, I'm not sure what to do. I thought it would crash before, but it looks like it saves it on the level above sometimes. All right, what's the field name? That's the one I'm making up. I think we called that Origin. What's that? Origin area. I'm going to do something a little different. I'm going to actually put this up here and call this Origin. I'll just call this O area field equals this. The reason I'm doing that is so that I don't have to write original area in my code multiple times. If you want to, that's fine, but I think it's best practice, anything you're going to reference a lot, to put it as a separate variable. Same with C tracks, because I'm going to use this multiple times in my code. So I'm going to put this in data, something like that. It stands for input data. C, I'll call this in data. So now, what happens, what I've done is I've just replaced these with variable names. So now, when I calculate the field, I just feed it in data again. That way, if I ever want to change the input up here, I can change it. I'm generalizing the code.
And you don't have to use quotes. because it's a variable.
Right, you don't have to use quotes because it's a variable. Exactly. So you're not feeding it literally in data, you're feeding it the variable, and the variable contains this data. So now that we're out of work, let's do one more. Analysis tools, no wait, management, and we're going to do fields, and we're going to do calculate field. And I'm going to get the help here. Just going to copy this last line here. Paste it in here. And so my in features are still going to be the same in data. My field name is actually going to be O area field. Now my expression is going to be a little different, and I'm going to make sure it's Python expression. Just a plain old Python. What's my expression going to be again? Does anybody remember? If it's Python expression? Yep. Yep, exclamation point, shape, underscore area, exclamation point. And I'm pretty sure that it was mixed case like that, but let me look. Because I forgot. Shape area, yep, it's a mixed case just like that. I'm gonna remove this so that it doesn't conflict though. So now that works. And I can actually run it at this point. But I'm gonna run it, and then I'm gonna verify that it worked. So I'm gonna run it, invalid syntax. Oh, I forgot to close this. I'm gonna run it. Looks like it ran. And I'm going to add it in really quick. Oops. Okay, so now it's not letting me get to the data because Python's still using it, I guess. It's done now. There it goes. It was taking longer than I thought to run it. So now when I open this up, I should have that field, have that original field. I calculated it worked. Everything's good. Now, I'm going to try to run this again and see what happens. Because I'm running 10.5, I think, on this computer, but I'm pretty sure you guys are running earlier versions. I'm not sure exactly where they changed it, so I'm interested to see. I want if everybody's got it, try running it again and seeing if it fails on this add field. If it does fail on the add field, you'll need to manually delete that field before you can run it again.
So we need to go, I've already deleted the original area we created.
Yeah.
Is that what you're talking about?
Yeah, but I'm just saying, once you run this again, it'll create it again.
Right.
And for me, because I'm running 10.5, it ran just fine for me. So even though I told it to add a field, it said, oh, that field's already there. That's cool. But I know at some earlier version of 10, I forgot where it was, if you tried to add a field and it already exists, it would throw an error. But ArcGIS changed, ESRI changed that at like maybe 10.1, but maybe it was 10.2. I think you guys down on the coast are already running 10.3 or 10.4, so maybe it's not causing 10.5 even. Okay. Up here, I think we're still running 10.2 or 10.3. Whatever we're running. I mean, what is it? 10.5 too? Okay.
The tree was that, remember when?
Oh yeah, we went and reinstalled everything. Thanks, Ellen. All right. So you guys won't have that problem. I just from times I've taught this course in the past, and whenever I went to add a field, sometimes it would error out if that field already exists. It doesn't do that in Fine. Okay. Okay. So now all you have to do is fill in these last four. This is actually logically a much easier lab than you've had in the past. Now we're gonna build more into it later, but in terms of the code, it's just sequential this week. There's not any looping or anything like that. We'll build into that, but for now, just for today, I don't want to bite off too much. We want to just practice calling ArcGIS toolboxes from ArcPy. So literally, there isn't anything else to do besides add 4 lines of code. There's 1 line for each of these. You just have to know which fields. Sorry, 1 line for each of these. You just have to know which fields to put in. So 1 line after each of these, and you'll be fine. So most of your errors are going to come because you tried to write to something that was either open in ArcGIS or it couldn't be written to for some reason. So your path name might be wrong. Or you just put the wrong variable in the wrong place. All right, so I'm going to save this, and I'm going to stop this guy.